Growing up in rural Kentucky, Robert Grubbs spent the majority of his childhood helping his father and uncle maintain their farmlands. It was natural for him to choose the University of Florida as an agricultural chemistry major, a field which combined his interests in science and agriculture. At UF, he was mentored by organic chemistry professor Merle Batiste, who introduced him to organic research. Upon graduation, Batiste encouraged him to continue in his chosen field. Grubbs attended Columbia University, where he received his PhD, then traveled out west for his postdoctoral work at Stanford University. In 1978, Grubbs accepted a faculty position at the California Institute of Technology.
I'm Robert Grubbs, professor of chemistry at Caltech. I was lucky to win the Nobel Prize in 2005 in chemistry. You know, I didn't really know what a scientist was. I grew up in a very rural background. I remember overhearing my parents saying, he's going to be an inventor someday. But they didn't know what that sort of meant. It just, I always made stuff, was always worrying about how things were put together. I discovered that I really liked organic chemistry, I really liked working in an organic lab, and I actually had some talent. It was sort of the first thing I found I really had a talent for. You know, what I did to win the Nobel Prize in a simple way. So what we study are catalyst reactions, and so these are reactions that you can mix two chemicals together and they will stay for a very long period of time, and then you add the catalyst and then things happen. So the catalyst is what causes the two chemicals to react with each other. So first thing we had to do was to understand how the reaction happened. How you could put in a metal complex and it would break a bond apart and put the pieces back together again. So that was really fundamental work, and that's really what we started on. Once we understood that, then all the other work then flowed from that. The kinds of molecules that we work on are called olefins. These are carbon compounds that contain two bonds between carbon. Most, like gasoline, has one bond between carbons, and these have two. And so the catalyst that we work with breaks those bonds and reassembles the fragments. And so it's really a new tool for building organic molecules. The applications now that are developing range from a new hepatitis C treatment, and one of the molecules that is involved in that new treatment, which finally cures hepatitis C, is a molecule made using our chemistry. There are other applications where we're making polymers. These are plastics, and one of the big applications was insulation for pipes that are going into deep sea drilling. So the nice thing about it is that it goes from really special molecules to really sort of big bulk molecules, and it all uses the same catalyst basically. I always said I would have come to Caltech for a tent in a parking lot because of the students we get here and the atmosphere here. We have people coming from all over the world who come and want to work in the group, and they operate because they're excited about what they're doing rather than because there's competition. My job at this stage is trying to keep them sort of focused in the right kind of directions and hopefully providing some exciting problems, and then mostly stay out of their way and let them go. How often do you have a chance to, have 20-year-olds, 21-year-olds show up in your office and say, let's be excited about working on something. Let's try to solve an important problem. And how often do you have doctors wander into your office and say, if you can solve this problem, it's really going to help people. So it's a great job. One of my colleagues and I look at each other regularly and say, we have the world's best job.